Morning, Dr. Salman. I'm Yipin. I'm the lead presenter for our group today. On behalf of my team, I welcome you to our presentation for RMT 550 Stakeholder Management and Project Cost Management. Our presentation focuses on the critical intersection in our industry. The title of our study is Procurement System Contractual Challenges and Their Impact on Construction Costs. We are here to demonstrate that the selection of the contract model is the single biggest predictor of our project success. Let's begin with the origin of our presentation. This is our presentation outline for today. It consists about 4 parts. Part 1, introduction. Part 2, the 3 pillars. Part 3, the issue. And Part 4, the reflection and conclusion. And let's start by Part 1, the introduction. Before we dive into the data, I want to briefly share how we arrive at this specific focus. Looking at the standard relationship between stakeholder management and project costs, however, we introduced the contemporary issue of sustainability and we found a theoretical break. We realized that we cannot simply add sustainability to a project without breaking the traditional financial models. This led us to a critical hypothesis. The root cause of project failure isn't the design or the technology. It is the procurement system itself. The way we buy construction, it's broken. The broken system is captured perfectly on this next slide with a fundamental truth about our industry. Every construction project tells 2 stories, the budget story and the outcome story. They rarely align. This visual represents the core challenges we face. On the left, we have the budget story, where the traditional procurement focuses entirely on the cost estimates and the theoretical savings. On the right, we have the outcome story, the ultimate reality of quality, functionality, and client satisfaction. The critical issue is represented in the center, the fundamental misalignment. Under the current models, the inputs of the budget story do not naturally connect to the successful outcome. The bridge between the plan and the reality is missing. Therefore, the selection of the suitable procurement system sets the team motivation, determining if they profit from conflicts or efficiency. This alignment isn't just theoretical, it's the harsh reality that manifests as a chain reaction of failure. As this slide illustrates, we are dealing with a systematic issue. It starts on the left with cost overrun. Traditional incentive leads to low bids that resulting in 10 to 20% global effort overrun. Following to the center, this financial pressure furthers trade-off, leading to missed sustainability targets in 70% of the project, as long-term value initiatives are the first thing they cut when the budget is tightened. Finally, on the right, the dispute and conflicts on the contracts creates the constant frictions, resulting in significant schedule delay averaging 3 to 6 months per project. These failures aren't just random, they are structural. They are the consequences of how the project team chose to procure. To fix these systematic failures, we must first change how we perceive the function itself. As this slide summarizes, procurement is not just an administrative purchasing function. It is the strategic lever that dictates the project structure across 3 critical domains. On the left, stakeholder engagement. It determines if we have transactional relationship or active risk management partnership. In the center, financial management. It defines the project entire risk profile and it determines the final price certainty rather than just estimating initial costs. And on the right, design economics. It dictates the balance between cost and value, determining if we achieve innovation through integration or merely traditional cost cutting. The fundamental rules have changed. As our slide shown in the center diagram, sustainability has forced its ways as a disruptive fourth constraint alongside with cost, time, and quality. The problem is that traditional procurement shows on the left with its fragmented structure, it is incapable of managing this complexity. It is built to fail the net zero objective. To succeed, we must move to the right platform, the integrated procurement. Only through collaboration and shared incentive, we can turn this sustainability into a competitive advantage, achieving significant waste diversion and cost saving. The conclusion of this introduction is clear. Achieving project success today is a structural issue. The procurement model we choose dictates the project success. The rest of this presentation, we will examine how we make this strategic shift.
Today, I'm going to present part 2, Program Learning Outcome 1, Stakeholder Engagement. Let's talk about the stakeholder engagement. Stakeholder engagement is interactive communication that identifies the conflicting priorities before they escalate to dispute. It involves between 2 key groups, which are the internal delivery team, consultant and contractor, and external group like regulatory bodies. We need interactive communication to align the interests that are often naturally divergent. When we identify the technical constraint early in the design phase, we significantly minimize the late-stage rework. It shifts the team's focus from protecting their own liability to achieving the collective project goal. Next is about the engagement fundamental interactive communication as a risk management. Let's look at the traditional procurement first, which is design bid build. In this system, roles are strictly fragmented and sequential. The client acts as the central hub, hiring the consultant to finish the design before the contractor is even appointed. This creates a major structural flow. The contractor has zero input on the design process. The architect will prioritize the aesthetic, often ignoring the practical constructability. It will cause a high risk of misinformation and misunderstanding. Now contrast that with the design, build, and integrated project delivery. This system fundamentally restructured the role by unifying the accountability. In design build, the contractor leads the engagement and the architect will become a collaborator within the supply chain, balancing aesthetic with value engineering. These evolutions go even further in management contracting and IPD, where we introduce early contractor involvement. Here, the contractor is paid to join the design phase, not to build yet, but to consult as logistics and pricing. Slide is about contract type determining competition and collaboration. In traditional system, we typically use lump sum fixed price contract. Because the price is fixed, contractors often bid low to win the job. Then to recover their margin, they are financially incentivized to create the claims and dispute whenever a problem appears. This will result 10 to 20% cost overrun. In contrast, the cooperative arrangement often use target cost or share sharing contract. The logic here is very simple. If the project comes in under budget, everyone will share the savings. Everyone will benefit from early problem solving and making transparency rationals. This will result 2 to 5% cost variance. The next is about lesson for practice. First, timing determines cost. If engaged contractor early can save up 5 to 20% of cost, so involved contractors early can keep the optimization window open while costs are low. Second, incentive drive behavior. Ultimately, contract structure is more powerful than team culture and have aligned financial incentive with project goal. Third, engagement is structural. Traditional procurement build wall between designer and builder. Design, build, bridge them. Choose procurement that build the bridge. Lastly, is the strategy recommendations for the stakeholders. First, for the client, stop wishing for teamwork within advisory contracts and they must structurize it. Shift the focus from the lowest initial price to the total life cycle cost and incentivize efficiency, not claims. It will provide the higher value outcome. Second, for the designer, they need to end the throw it over the wall mentality. Invite contractor at the early stage, it helps on optimize the design and cost. Lastly, for the contractor, stop being a bidder, but start as a design collaborator. They must reposition as value partners. It will having the result reduce risk and have a higher margin. That's all for my part. My teammate will going to present the next sections. Thank you.
This page is about financial management and procurement systems. Traditional models have 10 to 20% extra costs. They make money from arguments, but integrated systems only have about 5% cost changes, and profit comes from working well. Clients can't control costs just by saving money. They need to choose systems where cost control helps everyone make profit, not just limit spending. Now, let's look at core financial problems in construction. First, bad cost planning means budgets are too low and change a lot. Then, slow or poor cash flow can push even profitable projects into trouble for builders. These issues together make more arguments and break the trust we have in cost control. Now, let's talk about how to keep costs stable. First, don't just note down spending, manage cost risks actively. Then, how we pick suppliers and make contracts. decide who takes on cost problems. Finally, stable costs don't come just from good budget guys. We need to make financial and supplier choice earlier. Let's cover 3 suppliers options and their cost impacts. First, traditional. Teamwork apart, leading to arguments and big extra costs. Then, design and build. One team handles design and build, so costs stays steady. The last one, management contracting. Builders join early. This is flexible and keeps costs reliable. This choice helps teams work better and lower risks.
Everyone, I'm member 4. My name is Zhao Hongxin, and today I will be talking about design economics. To start off, my key event is actually quite simple. Cost is a consequence of design. If you look at this magnetic curve on the screen, it shows something very important. Even though design fees are small, earlier decisions actually knock in 18% of the total cost. The logic here is clear. If we change the design early, it costs almost nothing. But if we change it later during construction, it becomes very expensive. So we must make the right decisions at the start. On to the next slide. Let's talk about value engineering. Now, a lot of people think this just means cutting costs, but that's actually wrong. True value engineering is really about balancing cost and function. So bad VE is just cutting quality to save budget, but good VE is what we call optimization. So the question is, how do we achieve this? Well, it really depends on procurement route. I compare the two main route model here. First, we have the traditional route. The problem here is that it's fragmented, so the builder comes it too later. This makes optimization reactive. Basically, we only cut cost when it's too late. On the other hand, if we look at design and build, it's integrated. The builder comes it in early, which makes optimization proactive. We save money before the price is fixed. We found is that traditional route block optimization, while integrated route enable it. Finally, I want to share my reflection and lesson learned. The biggest problem in our industry is the gap between designers and builders. The solution to this is ECI, earlier contractor involvement. We basically need builder to join design phase. To conclude my part, I learned that collaboration is the ultimate money-saving strategy. We must stop looking at the lowest bid and focus on life cycle cost over 30 to 16 years. Okay, thank you. Now I will pass to member 5.
Next, let's take a look at part 3, the issue. The issue, sustainability consideration. We are witnessing a fundamental market failure. This slide visualizes a compatibility error between our new regulatory reality and our old purchasing habit. First, look at the shift. Sustainability has evolved from voluntary enhancement to a mandatory baseline. This is no longer about corporate social responsibility, it's about market license to operate. With net zero commitments and strict environmental certification, a non-sustainable building is now a stranded asset. It has no long-term value. Now, let's look at the conflict below. While the goal have changed, the mechanism has not. We are attempting to deliver this complex mandatory outputs using a cost-centric procurement. This system prioritizes sequential delivery, design first, price later. This creates a structural paradox. We ask for life cycle performance in long term, but we select teams based on the lowest essential cost. There will be short term. The tools we are using effectively forbids the outcome that we need. The previous slide defines the problem. This slide defines the structural mechanics of the solution. It proves that timing is the currency of sustainability. The top diagram establishes our theoretical framework, the procurement architecture. Most clients think they buy sustainability through technology such as solar panels and green concretes. This model proves that they actually buy it through the structure. The contract defines at risk allocation and incentives. If the contract punishes innovation, no amount of technology will be safe to project. The bottom diagram applies this to in reality. It compares two timelines. The traditional timeline in red, the contractor arrives after the design freezes. At this stage, sustainability improvement is a variation. It costs money and causes delays to the project. We call this compromise sustainability. The integrated timeline, which screen. This is early contractor involvement, ECI for short. By moving the contractor entry points to the left, we unlock pre-construction expertise. The conclusion, we do not need a smarter builders, we need it earlier ones. We lock in the life cycle saving by changing the schedule, not just the specification.
This brings us to the first impact area, stakeholder engagement. Sustainable projects introduce a coordination complexity that traditionally systems struggle to manage, involving regulator, certification body, and waste manager from the outers point one. In Malaysia, this includes CIDB, MGTC, MICRES, and GBI assessor, licensed waste contractor, and increasing green finance institution, all of whom influence project decision early on. Secondly, sequential procurement limit innovations by following a rigid design then bid approach, which restrict early contractor and supplier input and result in sustainability target being set without constructability or supply chain validation. This has been absorbed in several public projects pursuing MICRES rating, where sustainability targets were defined at the design stage, but contractor later report limited availability of certificate recycled aggregate and low carbon concrete, leading to redesign and cost adjustment during construction. Thirdly, sustainability projects require expanded stakeholder involvement, now including financials, supplier chain partners, and waste manager stakeholder, far beyond the traditional team. For example, Malaysia project applying for green technology financing scheme incentive must align procurement decision with financing requirement, further expanding stakeholder coordination demands. And fourth, the lesson is clear. Early involvement improves delivery. In summary, effective sustainable delivery require a shift from sequential to integrated. Early stage collaboration, procurement model like design and bid are not just contractor choice but essential framework for embedding constructability, innovation, and verification into sustainability goal from the very start. Next, we move on to the second impact area, which is financial management, where we see 5 key shifts. First is the tension between capex and lifecycle costs. While sustainable material and system often raise initial costs, there is significant reduced operational and maintenance expenditure over the building life. This is evident in Malaysia Green RE certified office development, where higher upfront investment in evident facade and HVAC system have resulted in substantial lower energy bill and improved long-term asset performance. Second, lowest price evaluation pitfall mean traditional tender access focus solely on capital costs, leading to the rejection of options that are financially superior when evaluated using life cycle costs. Many Malaysian projects still follow lower pricing tendering, causing energy efficiency system to be removed during value engineering despite proven life cycle saving. Third, financings and asset value are now directly influenced by procurement decisions. With green finance incentive and carbon-related risks affecting borrowing costs and long-term performance, projects aligned in sustainability benchmark are often better positions to access green financing and avoid future brown risks as regulation tighten. Fourth, strengthening cost management with life cycle costing align financial decision making with long-term project value rather than short-term saving. And fifth, this alignment enable sustainable solution to be delivered during without compromising cost efficiency or constructability. In short, adopting life cycle costing transform procurement from a short-term cost exercise into a long-term value decisions. Finally, let's look at design economics, where early decision had irreversible consequences. First, early decision lock in more lifecycle costs and carbon outcome, yet contractors are traditionally engaged too late to influence them. In Malaysia, many commercial and mixed-use projects finalize structure and material choice before contractor involvement, limiting opportunity to reduce embodied carbon later. Second, circular economic integrations through strategy like design for disassembly and material use depend on early collaboration with contractor and supplier to reduce embodied carbon. Local examples include project exploring modular system or recycled material that were later abandoned because procurement did not support early supplier validations. Third, let's check value engineering often strip out the environment performance feature rather than optimizing them, weakening sustainability. This was turned in common in Klang Valley development, where green facade system or modular component are replaced with conventional alternative at tender stage to control the upfront costs. Fourth, integrated procurement model maintain the opportunity to optimize both economic and environment performance by aligning contract with collaborations. And fifth, aligning procurement with design economic enables sustainable delivery without compromising cost efficiency or constructability. Integrated procurement is critical to ensuring that economic optimization and sustainability intent are pursued together, not in conflict.
Hello everyone, I'm Hu Beili. This slide shows our mission. In Malaysia, more project system use traditional procurement. This system look only at initial cost, not total life cost. Because of this mass scalability, targetless fly. Great design look expensive at the start, so it is often restricted. Our recommendation is simple. Clients should move from design build to integrate system like design and build. This over early contractor involvement when carbon contract is cheaper and incentive. This slide is about the supply chain. The supply chain should not only build materials, the should also help with idea and technology. We lost passes cause problem. Make carbon data hard to see and hard to trace. Construction should help with accessibility, not only do the building work. Consultants should use BIM not only to draw, but to track carbon and cost beef construction. This slide is about cost and carbon. Choosing a country is not just paperwork. It can change the carbon result of a project. In the future, green rules will not be optional. Carbon reports and life cycle costs will be required. To do well, people must list new success. Contractors should join early and designs should use BIM via carbon data.
Take a look at our last part of our presentation, part 4, reflection and lesson learned.
Let's look at the real barrier. Why is sustainability failing? It's not about technology, it's about the system. Look at column 1. We actually have great policies like the 12th Malaysian plan, but this clash with old school procurement methods that break the process apart. Then, look at column 2. Is a money conflict. The current system forces us to choose the lowest initial cost, but green buildings need us to look at the long-time value. We are being penny wise but pound foolish. Finally, in column 3, is a timing issue, but the time we hire is burst. The design is already locked. The window for innovation is closed. So, the system itself is blocking our way. So, how do we fix this? We need 3 major shifts in our thinking. First, governance. Procurement isn't just paperwork, it's a strategic choice. The system you pick directly decides how green your building will be. Second, the rules. We are moving from voluntary to mandatory. In the future, things like carbon reporting won't be optional. They will be the law. We must be ready for this baseline shift. Third, skills. The industry needs to upgrade. Contractors need to get involved early, and the designers need to use data better. The key message is this: if we want different results, we have to change the rules of the game. This brings us to the solution, the path forward. In panel 1, we see a gap. We have the policies, but we can't implement this because our contracts are too rich. The bridge is in panel 2. We need integrated procurements. To make this work, we must share the risks and share the rewards. When financial incentives match our climate goals, everyone moves in the same direction. Finally, the verticals. Why does this matter? Because construction creates 24% of our national emissions. So, choosing the right procurement system isn't just a business decision. It's Malaysia's climate choice. We must bridge the gap.
Presentation lead us to 3 conclusions based on our objective. For Flow 1, we proved that financial certainty does not come from rigid contracts, it comes from stakeholders' alignments. If team fights, the budget fails. For Flow 2, we demonstrate that green goals are structural. We cannot deliver a net zero building with a procurement system built for the lowest initial price. It requires integration. Finally, for Flow 7, the lesson is clear. The contract is the strategy. To fix our industry inefficiency, we must stop buying the lowest bid and start procuring for the best value. Thank you.